Certified Penetration Testing Professional, Module 5, Network Penetration Testing External. So in this module, you're going to learn how to implement a comprehensive penetration testing methodology for assessing networks from an outside perspective. So network penetration testing is all about identifying the security weaknesses in the network infrastructure. We have to do it from outside of the organization, and also once we're done, we do inside. So we want to perform both an outside test or an external test and an internal test so we can do comparisons. Because remember, the breach can happen at any point of the network. So when we're doing penetration testing, we want to take that position of any breach. All right. So we normally have a methodology for testing a target's network infrastructure. We look for open ports. Remember the attack surface. Open ports represent the attack surface. The services running. Any sensitive information exposed through default banners, services, those types of things. We look at firewalls. Can we bypass the firewall? We look at intrusion detection systems. Can we evade it? Some form of obfuscation. And then we look at switching and routing issues to see if there's things we can do to penetrate or bypass the layers of protection between us in an external position and the target. So it helps the administrator look at the actual network from the perspective of somebody who's going to target it. And remember, what we're looking for, are they following best practices? And best practices are principal, least services, least privileges. Their attack surface should be the minimal attack surface required for carrying out the business or the mission need. And then what we want to do is see if they're following the best practices and not leaking information. So when we do an actual services or a banner grab, we want to make sure we don't get anything back from that. If we do, that's a finding for the actual client. And then we want to try to do what? Gain access. So as the pen tester, we're still doing the same process and methodology we follow all the time. The difference is now from an external position, we're probably going to have to deal with a filter between us and the target. So we want to teach you in this section and how you actually do this is how to determine, number one, if a filter is between you and the target, and number two, what rules are open or allowed through that filter. Or the other way is to bypass the filter. Remember, if we've got a device, firewall, router, whatever it is, between us and the target, and it's doing some form of filtering, we have to either bypass that filtering, or a firewall rule in the case of a firewall, or we have to attack it itself. If we can't do either of those things, whatever attack surface, because of what the rule or the filter is allowing, that's all we're going to be able to test. And that's the important thing to actually understand. And with CPENT, we want you to understand when you're in an external position, you're going to be faced with these types of hurdles and obstacles. It's up to you to analyze what the network's telling you and determine how to bypass or attack the device or the filter itself. So external, as we said, we know we're going to have to deal with filters. We're going to have routers. We're going to have firewalls. We could have a wireless access point, right? All those types of things. The difference with internal is we're inside already. We've got the servers, we've got the workstations, the endpoints. Sometimes we'll run into a device boundary in the case of an OT test versus an IT test, stuff like that. But in most cases, we're not going to have an actual device doing filtering. It's not going to be a firewall device. It's not going to be a router once we're inside the internal testing network. And we got a whole module that we'll talk about internal testing. So with external network testing, as you look at this diagram here, you're out there in that external position. Well, what? First thing, if it's not a router, it's a firewall. So how are you going to break through that firewall to get to the other side? You might not be able to. But our job as testers is to find out, based on the level of skill set that we're emulating, what's the attack surface going through the filter. So now we have a little bit of a different challenge, because if that filter has 2 ports open, that's the attack surface, unless we can bypass it. You might only have that 2 ports to deal with. So in the example here, you see the DMZ. It looks like the public services DMZ has web and mail. So in most cases, that means it'd probably be 80, 443, and old school mail would be SMTP port 25. Newer school would probably use 936 and some of the other ones that are encrypted protocols. It doesn't matter what ports are open from the perspective of how they're providing their services. What matters is you have to be able to do what? Map that attack surface. So if that filtering device only allows 80, 443, and we'll use 25 as I said for simplicity, that's 3 ports of attack surface. If I can't bypass that firewall, that's the only 3 ports of attack surface I have. Now we have different techniques and we'll talk about different things, but I want you to understand that reality. And when you go and you actually sit and you try to get your CPENT, and moreover maybe get the 90 percentile and make the LPT master, you're going to run into filters. You're going to run into rule sets where you have to map the attack surface through a filter. And that takes analysis to understand, once you get that attack surface, how can you leverage that attack surface even though it's through a filter, right? So that's what's the importance of external testing. We'll get into that directly when we talk about perimeter type testing. So the internal testing, as we said, we're already inside. So when we're inside, it's a lot different. We don't have that perimeter firewall anymore. So you can smile and say, I'm inside. I'm already in that network. I can connect in a lot of cases because of unused ports that are allowed and active and enabled. That will give me an IP address. That'll give me all this other type of stuff. If I'm external, I don't have that luxury. I have to go send data in, part of our scanning methodology, look for live systems. But if it doesn't allow ICMP, no ping sweep's going to work. I have to use TCP sweeps, stuff like that. So you have to start thinking that way. And you especially have to start thinking that way, not only for industry to go out and do pen testing from an external position, but if you want to sit for the CPENT, you better be able to think that way as well and do analysis and identify what filters between you and the network or the target that you're targeting. So what's those steps? It's no different than before. Open source intelligence, port scanning, OS and service fingerprinting, if you can, vulnerability research, exploit verification, and reporting. Same thing we've done before, but the only thing that's changed, the position of where you're doing the test from. And that's extremely important because an external test, as we said already, you're going to run into obstacles. You might even run into them in the internal side because sysadmins are getting stronger and smarter, but for sure on the external side, you're going to run into them. If you don't, that's an easy write-up for your report. When you do, now you have to see, number one, the rules that are configured through it. Number two, are there any vulnerabilities in it? Give you an example. When we do our vulnerability research, we know Cisco ASA has had some recent news and a lot of vulnerabilities recently, stuff like that. You would have to be able to know that when you determine if it's a Cisco ASA firewall. So you have to do different work and stuff like that. The other thing you want to be able to do is see if there's any way to bypass it. So if the rule in place has what we call weak access control lists, in the case of a router, can we use fragmentation? Because remember, a router is primarily a stateless filter. What can we do to bypass that stateless filter and get to the other side? That's critical when we do this stuff. So now we go back to our testing. Remember, white, black, and gray. If we're doing external testing, the more information they give you, the better, right? When they provide it, they give you more information, makes it easier to do the test. That's the white box penetration testing. If they don't, we have to do more work to be able to do the test. Black box, as we said, sometimes they only give you a domain name. If they only give you a domain name, IP addresses, then we have a lot of time-consuming work to do, and that's an expensive test. Your client has to understand that. If they're willing to pay for it and they want you to do that, that's fine, because in most cases, that emulates typically what an external threat or an external attacker would be able to do. And then gray box, we're going to blend it. We're going to get some of the information about the actual client, some of the information about the network infrastructure, but we're not going to get everything. But we're going to get more than we would get with a black box test. So now let's talk about port scanning. The key with port scanning is if I'm sending a packet into a network and it's on an internal test, it's easy. A SYN goes in, open a connection with me in the case of TCP, a SYN-ACK comes back. But what if I send a SYN in, get a reset, of course, port's closed. What if I send a SYN in and get ICMP back? What if I send a SYN in and get nothing back? There's got to be a device. There's got to be a filter. So now you have to be able to analyze that to determine if the device or the filter is IP tables, if the device or the filter is some other type of firewall. There's all these different types of things you can analyze to determine that. In the port scan, we want to go, first we need live systems, right? Once we find the live systems, we want to map the attack surface. It's no different than anything we've done before. The only difference is the position. So by the position of the test, now we're not going to have that simple scan that's probably going to come back with all these ports. In most cases, you're going to have to disable ping in the actual target. And in most cases, you're going to have to use a TCP sweep to get the live systems. And then once you get some ports, you might be able to get enough to fingerprint the services running on open ports. Now, in the case of Nmap, it needs at least one open and one closed port to get the stack fingerprint to try to map the actual operating system to one of its database fingerprints. And then once we get that, we've got doors. Once we do doors, it's the same concept from before. We're going to do our services scan to see what data we can extract from those ports or those doors of that attack surface. Once we extract that information, then we're going to do our research to see if we can find vulnerabilities, right? So, of course, we said a ping sweep from the outside world is probably not going to work. So instead, you're going to use a TCP type of packet or just scan the ports. You can do the port scan and do the range, and now you'll send the packets to the popular ports, right? Different types of things. You can send them to all 65,536, but it's going to be slow and time consuming. Of course, you have Nmap. Netcat can also be used as a port scanner with -Z and a -W option for the write and those types of things. It's a limited type of port scanner, but can be used. And then the other favorite tool we like to use is HPing. Remember, CEH taught you, if you've had your CEH, tools, lots and lots of tools, more than 2,000 tools in CEH. What you want to do now is you want to take it to the next level. So what you do there is you take each step of the process and methodology as you learn it, and we've been teaching it here. You take each one of those steps, and you get 2 to 3 tools for each step. You master those 2 to 3 tools, and that's what you use when you do your assessments, right? So that's why we give you all those tools in CEH, so you get introduced to a lot of the tools, and then in your own laboratory environment, or in the iLabs, if you have iLabs access, or however you're doing your actual lab practice, you practice with those different tools, and you select the tool that works best for you. Everybody has different requirements for tools, so pick the one that works for you. Match the tool to yourself. So the first example here we have is for ICMP scanning. Now the old school way is the lowercase s, which of course in Nmap means the scan option, and then you got the uppercase P. That's a ping sweep. The new way, as you see here with Zenmap in the GUI and in the bottom with the actual image, is -lowercase SN. Now all that says is the S is always scan. The N says no port scan, and that's all it really does. It doesn't matter how we do it. It's the same concept. More than likely, ICMP is not going to pass through the firewall, so this scan will fail in most cases from an external position. And you'll usually get an error message from Nmap that says, is the target blocking our ping probes? If it is, use -uppercase P and lowercase n to not ping the target, because Nmap will ping the target first before it runs its scan. And here's different types of information. As I said, if you send a packet, a SYN packet, into a target, and that target responds with a SYN-ACK, port's open. If it responds with a reset-ACK, port's closed. If it doesn't respond at all, port's filter. If it responds with an ICMP, it depends on the type of the ICMP, and that's why we got the information here for you. Type 3 ICMP stands for destination unreachable. Code 0 means I can't even find a network. I got a routing problem. Remember that. If you're on the outside and you're trying to get to another network, you have to have a route. If you do not have a route, you will not get there. That's rule number 1 in your testing. I can't tell you how many people do not understand this concept. Do not go and try to scan something of a network that you don't have a route for. If your default gateway is pointing the wrong direction, it's never going to find the network. Make sure you remember that when you go in, especially, and sit for the CPENT or the practice range. Now, destination unreachable type 3 code 3 means I found the network, I found the host, but the port's unreachable. All right? The ones you want to focus on that are traditionally not really covered that well is ICMP type 3, again, is destination unreachable. The code tells why it's unreachable. And why it's unreachable is because type 3 code 9, network administratively prohibited. That means the entire network has a rule that's being blocked. This is usually IP table's response if the administrator is not following best practices. Because in the rule set for best practices, you don't respond. It just comes back with nothing, and all you get is a filtered. Type 3 code 10 means it's not the network that is filtered, it's the host itself. That's important because you can try other hosts, but the host, whatever host returned that, is filtered, all right? So this is why we said from the external position, you have to analyze that traffic, right? Have to analyze those targets. These are the types of things you have to be able to do. Okay, now, type 3, destination unreachable, code 13, communication administratively prohibited. This is usually from a router access control list. Moreover, in most cases, vendor specific, Cisco routers usually do this and behave this way. It also tells you, and this is a finding for you, the administrator has not done best practices on their configuration of the router, because the router should respond with nothing. If you respond with nothing, that's better than responding with an ICMP. But when you see that, you know you have a router access control list. This is critical when you do your testing, because when you scan the device, whatever ports come back is closed, there's a rule in that device for those ports. When you scan across the device, they'd be open because they're allowed through the device. That's how you determine the rule set on a device, a router, a firewall, or a filter. Again, you have to understand this when you're doing your external testing, and it's rarely taught. We've added into CPENT to make sure you understand this. All right. What about open ports? It's no different than all the other scanning you've seen and all the other scanning you've done. In the example here, we're doing -P-, which is what? All 65,536. And then the actual example below it, we start with port 1, and we do 65,535. But remember, when you do scans, there's a port 0. You may not have your tool, but you might have to write your own little routine to scan it, because possibly a sophisticated administrator could bind something to port 0. Even though it's not usually normal or stuff like that, unless you're using IPv6, we can actually bind things to port 0, we being the administrators. So just be aware of that. Of course, everybody knows Nmap. HPing, as I said, is a great tool as well. Remember those 2 to 3 tools. Of course, Nmap's going to be one of them, and maybe HPing will be your other. Depends on if you want a GUI, then you can use ZenMap. For some of you want to use that. And then you do a connect scan. Now remember, the connect scan, and this is all review usually for those of you who had CEH, we complete the 3-way handshake. In Nmap, it's the dash lowercase s, uppercase t. And the connect scan is the most accurate scan because when you use that scan, it will come back after completing the 3-way handshake. Right? So that's more accurate. The problem is it's logged by the target. So that's why in the past we said there's always a concern because the state of the socket goes from a listening state to an established state when you complete the 3-way handshake. And that's what the connect scan does. It completes that 3-way handshake, and that gets logged by the target because you have an established state in the actual socket of the actual machine that you scanned. All right? Now, OT, ICS SCADA networks, you have to use the connect scan. Do not use this next scan, which is called the SYN scan, the half open scan, or also known as the stealth scan. Now, originally it was stealth. It's not really stealth anymore. All it is a scan that sends a SYN packet, it responds with a SYN-ACK, and then you send a reset. So it does not complete the 3-way handshake like the connect scan does. And the reasoning was you used to not get logged. But nowadays, scanning, if you use default Nmap scans, which is the 1,000 ports, you're going to light up every intrusion detection system out there. So you have to be a little bit more diligent in how you do your scanning. Illegal flag combinations. They're possible, and they're here for a reference. In most cases, we don't get a whole lot of data back for these today. Most people know by the RFC, if the port is open, as you see there in the diagram, no response with an illegal flag combination. This is the Xmas scan, the null scan, all those other types of fin scans, stuff like that. If the port is closed, you send back a reset. The problem is Microsoft and other vendors do not follow this RFC guidance. Instead, what they do is any illegal flag combination to a port, if the port is open or the port is closed, it's going to respond the same way with a reset ACK. So since it responds with a reset ACK, guess what? That reset ACK means all ports are closed. So when you scan a Windows or a machine that doesn't follow the RFC with an illegal flag combination, all ports will come back as closed. One of the things you might do with this, if you scan and you see a port's open, you could change it to an illegal flag combination just to see if the port comes back as closed. Because if it does come back as closed, then whatever box the target you have is not following the RFC. We mentioned Windows here, but there's plenty of other vendors that don't follow the RFC as well, right? So it's a limited use. Plus, as I said, when you run this scan, you're going to light up every monitor there is because it's a very simple signature for your monitors to detect. So we can use an ACK flag scan. In the probe, as you see here, the example, when we do an ACK flag, you see when the port's closed, the window size comes back as 0. If it comes back as a non-zero value, the one we've got in the red box there, that means the port is open. So we can't rely on this completely because it really depends on the system you're up against. But it is one example for you. You might actually try it to see what happens. Where you might actually see it is in your OT or ICS SCADA networks, because these systems are traditionally older because of the long life cycle. So because of their long life cycle, you might see this type of thing. Or your IoT devices that have embedded firmware that's not been updated in a long time, those types of things. It's always worth a test, but just realize there's no guarantee this is going to give you the data you need. UDP scan. Well, remember, TCP is connection oriented. We have flags where we can establish connection. UDP is connectionless. We don't have flags other than flags for checksums and stuff like that. So what you have instead is ICMP. And remember, we showed the entire chart and the codes and the tables of the type of ICMP with the code. So now when you get an ICMP type 3 code 3, that's the response if a UDP port is closed. If the UDP port is open, there's no response unless there's a service. Example, DNS. If I query DNS on port 53, the DNS reply will come back and respond to me. That's a UDP packet for a DNS query. If there's no service sitting there listening, in the case of DNS, if there's listening, if nothing's there listening, it's not going to respond. It'll just come back and in map say open or filtered. If it's closed, it comes back with ICMP type 3 code 3, destination unreachable, port unreachable, as we've already talked about. And encapsulated or contained inside of that is the actual, so you got ICMP and then you have the UDP information of the port that was closed. So the UDP header is actually encapsulated inside of the ICMP packet that returns with the type 3 code 3 message, okay? All right. Now, we're in the external world. When we're in the external world, sometimes we can use a fragmentation scan to get through the filter. So that's the -F option. So you can try to do this, and all it does is split the actual TCP packets and headers over several packets. Why? It makes it harder for the packet filter to detect. Works well against a stateless type of firewall or a router's access control list. It's always worth a test, right? Test it out and see. Because remember, when you're in the external position, you've got that device, that router, that firewall, or whatever it is, you got to see what you can map through that device. So fragmentation scanning is one technique. You go and look for DNS servers. UDP is the DNS query. TCP is the DNS zone transfer. UDP DNS queries probably are common. You'll see that. You should not see DNS TCP from your external position. If you do, then that port's open. Now, it doesn't mean you'll successfully be able to do a zone transfer. In most cases, you're not going to be able to zone transfer, as we've talked about before. But the port shouldn't be open. So that's a finding for your test to tell them, you've got attack surface here, your TCP 53 is open. Now, their response is going to be, well, yeah, but that's so we can do zone transfer with our trusted host. So what they should do then is put in a granular rule. And what we mean by a granular rule is they put in a rule that says this IP address can talk to this IP address on that port. That's best practices, right? So in your finding, you'd write up and say the rules are too loose. Okay. All right. TFTP servers. UDP port 69. Now remember, if we find TFTP, it's a great finding because there's no username and password required, and we can use it to connect and use commands and write data into the TFTP server. Powerful stuff. But you shouldn't really run into it. From an external position, especially if you run into it, it's a critical concern. Network time protocol. Now you're probably always going to run into this one, but your clients should only allow it for time synchronization. That means the time synchronization, remember we said before, should be granular as possible. So if they're not actually allowing the network time protocol to just a time server, or better yet, synchronizing over GPS, and then we can't do a whole lot with it, then, or the satellite, then what we want to do is we want to make sure they understand it's too loose. So our finding is the rules are too loose for the time protocol. The network time protocol is 123. Now, some organizations also allow TCP 123. This is one of the egress ports I like to use when I do engagements because time usually happens all around the networks because of the Kerberos time requirement for Active Directory authentication and Kerberos and all that other type of stuff. So all I have to do is look for that time protocol, or better yet, how about if I use my time protocol as my egress port? So remember, we're in an external position. So if you find a weakness, say you find a secure cell server running, you find a weakness where the password for somebody is root and Tor, right? We hope not, but it can happen. And when you find that, you need to create a shell. Well, you're not going to be able to push the shell down into that because you're going through a filtering device. So you have to use the reverse shell. Now the nice thing is Metasploit by default today will give you the reverse shell, but you have to select the egress port. Unless the administrator is allowing all your ports back, the 44 is the default port for Metasploit's shell to come back to you, the local port, L port, when you set L port. Unless the administrator is allowing that, your shell is not going to get back to you. Remember that. One of the key ports for egress, 123. Why 123? Because time's usually allowed all around the network. So time is usually something you can use to get through the network. Now, some of you are probably saying, well, what about 80 and 443? You can use them, but the downside is, and it's a finding if you do discover 80 and 443 is allowed from the target when you breach it, an administrator should only allow 80 and 443 outbound from a proxy. If they're not proxying 80 and 443, that's a finding for you. Because direct DNS queries, direct 80 and 443 traffic is what the modern day malware uses, right? That's 90%. 10% will actually look for your proxy and send it out from the proxy. But again, we want to understand that when we write up the findings for the client. So SNMP, Simple Network Management Protocol, of course it's a gift if you find it. It's really a gift if it's V1, and it's got the default community strings of public and private. You're probably not going to see it too much nowadays from the outside world, but you might, so it's in here. We hope that the administrators are following best practices, and you don't allow SNMP. 161, of course, is the service. 162 is the trap. You don't allow that UDP port or packet to be reachable from external position. If it is, that's a finding for you. Telnet's another one. From the outside world, enterprise networks, you shouldn't see it. Where you will see it, IoT devices. These IoT devices by default, this is the Mirai botnet, why it was so successful, has a port 23 open and listening. So you always want to test it if you're doing IoT testing, because you'll probably see it. We test it anyway because by default it's tested with Nmap. Just be aware, when we don't think we'll ever see it again in the IT world, we could find it not only in IoT, you might find it in ICS SCADA. Maybe that engineering workstation needs to do something. They don't want to go through the encryptographic and all the other stuff they got to do, so what do? They have telnet. So they telnet into the device. Those are findings for us. And remember, once again, when we're doing a pen test, what are we doing? We're emulating a threat, medium-level skill set in most cases, and then we're mapping that attack surface. And once we map that attack surface, we're looking for weaknesses. Same thing here. Telnet's a weakness. LDAP, port 389, Active Directory. Again, from the outside world, this should not be open. If this is open from the outside world, that's a concern, especially when it's 389, because 389 is not the secure version of LDAP. That's a finding for you as well. Same process, looking for different types of things. Net bias. Red alert, critical, flashing, everything else. WannaCry ransomware had this open. If your clients have net bias ports open, it's a critical finding because net bias, 135, 136, 137, 89, 445. Remember the vector attack of WannaCry ransomware, of course, was the famous port 445, as was the famous Microsoft Server Service Buffer Overflow 9 years before that in MS08067. These ports shouldn't be open to the internet. So when you scan these, if you see that critical alert, you have net bias ports open from the internet. That's a finding for your client. You see the closed thing here. If we're scanning the device directly and we're getting those closed, that means there's rules in there allowing that. We don't want to see that either. Citrix ports. Citrix is another software. Remember, doesn't matter what the software is. There's going to be vulnerabilities in it. That's why you have to keep doing your due diligence. You have to do research, 2 to 3 vulnerability sites. Keep looking for different types of things. Citrix, which runs on port 1495, has had all these vulnerabilities in it recently and stuff like that. So just be aware of that. Oracle, this is another one. Now, the way we enumerate the Oracle database is called the TNS listener, Transparent Network Substrate. Now, today, Oracle, when it's installed, has that disabled by default. But DBAs, the database administrators, because they're used to it, they love to use the TNS listener, which the port 1521 you're looking at here. So what they do is they open it. And when they open it, now you have a possibility of a finding, right? So you test for it, right? And it is tested, I believe, by the 1,000 default ports. NFS, now this is old school, but the network file system in the Unix world listens on port 2049. Now remember, you're going to go and sit for a CPENT. You're going to go up against an OT, ICS, SCADA type of network. These are older types of networks. So you have to remember some of these old school types of things to do your assessment. There's a possibility that port 2049 might be open. If it is, and you don't know how to do it, you might want to research a little bit of how to connect to NFS shares. And then we got all these different admin monitor ports, the HP, different manager ports for this, the 2301, 2381. These are all these different types of ports that could be open on the system. So we want to make sure that as you test and you map, so it's all part of what? In a black box test, you're blindly having to look for all this stuff. In a white box test, you should be given all this stuff. In a gray box, you get a blended type of stuff. So depending on what type of assessment you're doing and what information you have will determine how long you have to do these types of scans, which is why it takes a long time when it's black box. Now the other one's RDP, 3389, notoriously weak in enterprises. When you see it's open, you can actually try to leverage the attack surface from that because it's a remote desktop protocol. Different things we can do. So when we scan it, when we test it, if we find an open 3389 through, remember we're in external position, an open 3389 through a router or a firewall device, that's a huge finding. You're smiling from ear to ear with that because that means they're allowing remote desktop protocol from that external position where you're doing your testing. Hydra and brute force, anyone? Yeah, you start running password cracks and see if you can actually crack that RDP desktop protocol username and password. Sybase, port 5000, as you start seeing here, you get the idea. And from an external position, you first got to figure out what's allowed through the filter. If we only have port 22 and port 80 and 443, as we showed in the diagram earlier, if that's all that's allowed through the filter, there's no reason to test for all this stuff. Your attack surface is limited to that, unless you can attack the device itself, unless you can bypass the filtering of the device. And that's what you have to start experimenting with. That's what you have to practice when you get on the CPENT practice range. When you find devices, and they are there, you have to figure out, can I map the attack surface through it? Number one, that's step one. Number two, can I identify the device? Is it a router? Is it a firewall? Number three, what's the actual rule set? And can I defeat it using ACK scans, fragmentation scans, and all these other types of different techniques we're going to cover here. Because the reality is, in most cases, you're only going to be able to map the attack surface through what's filtered through it. And then if they make a mistake, we have to identify that mistake as professional testers. SIP, so if they're using the actual voice over IP stuff, that's the port for that. Again, it depends on your initial attack surface actual mapping. More ports for you for VNC. Again, I hope you don't run into VNC being allowed from the internet from every IP address. That's not a good thing for an administrator to do, but that is our task as a penetration tester. We have the task of finding out, do they allow this from anywhere, or is it granular? X11, same thing on Linux. From the outside world, I shouldn't be able to connect to the X11 ports and X server, because if I can do that, I can open up the desktop or the X windows of that machine in some cases. So it's port 6000. Shouldn't be there. But as testers, we have to test it. JetDirect, the old HP JetDirect printers, this is one that continually is left open. Don't know why, but you'll find it sometimes. So port 9100, if you find it, then you have an HP JetDirect printer. Or something on 9100. Could be something as a decoy on 9100, might not be. But you go through your due diligence and see if you can extract any information other than just the ports open. FTP, of course, port 21. right? Quick caveat for you, if you find port 21, remember port 21 is the actual command and communication for FTP, file transfer protocol. Port 20, if it's active FTP, is the data session. So what you can try to do is set your traffic to come up from port 20, see if your actual results change. We call this a source port scan. Possibility it will. Web servers, of course, port 80. Another one you can pretend to be coming from port 80 to look like return traffic to see if the stateful firewall inspection is deployed, or is a stateless filter like a router or filtering device that's just using stateless tables like IP tables, for example. 443, of course, secure sockets layer, right? The dash uppercase F on IMAP is the fast scan, right? I don't really ever use it, but you can use it. You can also use the dash uppercase T option, right? Remember, dash lowercase s is always for scan, and dash uppercase V is services. So you look in the results there in the images, you see immediately what? The services. Now you're going to start looking at that and try to map the attack surface. Now I'll give you a hint as you're looking at that services. You see that EXIM? EXIM? Yeah? That has been well known for vulnerabilities. How about ICS bind, Internet Security Consortium bind, the version of bind? That could be vulnerabilities. This is from an external position. That's a lot of attack surface. If I find that much attack surface from an external position, and remember, this is our practice site, certifiedhacker.com, that's a good find for the tester, a bad find for the people you're testing because they're not following any best practices, right? But that's our job as testers. We want to go through and see if there's different types of things we can find that the attack surface is going to lead to a weakness, and we can leverage that weakness and gain access. We can scan for Kerberos, the active directory of Kerberos, right? That's 88, port 88, to see if Kerberos is involved. Then we can start doing some of our different things. Remember when you do, if you go up and you do the practice range, or you go up against the CPENT exam, you have an active directory network zone. So when you're in the active directory zone, you're going to have a scope of work. With that scope of work, you're going to have to try to figure out how to get access to that actual zone. You got SSH on port 22, right? Your different SSH servers. We've already talked about that. Anytime you find SSH, number one, see if you can find a version of SSH. See if you can do what we call a rollback attack with SSH v1. Nmap scan might be able to get you the host key, so you can try to see if you can do any other type of keying things and stuff like that, but that's usually later when you get privilege escalation. And then try to brute force it. You got Hydra, you got a Metasploit module for that. Try to brute force the SSH with some common usernames. Or during your information gathering stage, you should have been creating a list of all the users and everybody you encountered in email addresses, all that type of stuff. It's well known that a lot of organizations use the same email address, like mine's K Cardwell. Then K Cardwell could be my login. That gives you a login for a potential SSH. So now what you do is you don't have to brute force and figure out the SSH username. All you have to do is figure out the password of the user. So you put in the user in your scanning tool, and then you load a password dictionary file and see if you get lucky, right? This is the way the process works. When you got a 22 secure shell, if secure shell in fact is running on 22, then you have to try to get access to it via that vector. Remember the famous motto, been saying it for many years. You don't always have to exploit the box to own the box. There's a lot of other ways to get on the box. Remember that. Open and close ports. Mainly open ports is what you want to do. And the key here is a target database. So we always say this concept, you map the attack surface. As soon as you get those live systems, you create a target database. Well, what do you put on that target database? The IP address, the host name as you have it, the ports that are open. Highlight maybe in red or highlight in yellow, whatever you do it, the ports that are of interest because you usually know these ports usually are well attacked and stuff like that, have vulnerabilities for them, so on. Right, Samba, SSH, all those types of things. And then under that, the services. What versions? Now, if you can, put a little table together and have the port and what versions of each software is on that port. And then your research comes into play. Now you got to start researching based on that attack surface. You got to research those versions. Remember I told you the XM software, the ISC bind, and then you got to start looking for vulnerabilities in the versions of the software that you've discovered in your actual testing. So now, let's talk about trying to operating system and service fingerprint from an external attacking position. Now, this should be made more difficult by the admin. If we can do this, then that's a finding to write up. Because if the admin's doing their due diligence, they're not going to give us information or information leakage. Inside, this is easy. Outside, takes a little bit more work, depending on what's allowed. So we can use the -O option in Nmap. It's always worth a try. The problem is, look in the red box there. It calls it pretty much every version of Linux under the sun. So it doesn't give us what? A good, finite, granular operating system detection. But it is a possible option. You can use it. We can do passive OS fingerprinting. We can set here, example here, we're looking at different things and we're seeing information. We can use the Netcraft site. There's all these different sites we can use to try to get the information from the OS, right? No guarantee we're going to get it. And no guarantee it's accurate. You can look at the patches, right? Patches applied to the server. So in Netcraft, if you can pull this up, potentially you can look at patches and extract information about it. That's a possibility. You know? Blending your open source intelligence data you should already have. And then you start fingerprinting the services. Now remember, this is dash lowercase s uppercase v scan. In this case, we're scanning all those ports that were open. When you're doing your testing and you map the attack surface, if our example we had 80, 443, and we had the actual mail port, could have been the XM port, we're just using 25 as a reference. That's the only 3 ports you need to scan. There's no reason to sit there and do the service scan on all 65,536 ports, or in the case of Nmap's default, 1,000 ports, if you know the only attack surface you have are those 3 ports. So if that ACK scan, source port, fragmentation scan, all those other types of things didn't give you any more attack surface than that 3 ports that you initially discovered, don't waste your time scanning everything else. Put your scans and concentrate on the actual attack surface that's available, because you're not going to get through anything else anyway. Unknown services, you can actually go and try to figure out different ways. These are different scans. We have aggressive scans, dash uppercase A scan, right? You can do that, try to go through the firewall. Remember, it depends on how much data first gets into the target, and then more importantly, how much data gets back. If you run into a good administrator, they're going to control and filter the egress traffic. It's becoming more and more popular because the egress traffic is how worms and malware and all that stuff spreads. So your administrators are filtering it more and more. Now, years ago, we used to have a technique called egress busting, where you could send an email into a client for information, and if they used HTML-based email, it would automatically connect back to my site and tell me what ports were egressed out of the firewall. Harder to do today because not as many people use HTML-based email, but it's a possibility. So you might want to try it. It's called egress busting. You can find research on it, I'm sure. It's an old technique, but some of these old techniques still work today if the administrators have made mistakes. And remember, that's their job as a tester. We want to find if the administrators are following best practices. If they are, great. Write up a finding that's a positive finding, a constructive finding. Don't always write up all negative. If there's good stuff you find in your testing, write that up as well. All right. You can use ID serve, banner grabbing, right? Telnet, Netcat, all these are different mechanisms we can use to grab the banners. And remember, it's a finding if you find all this leaked information. If you find the Apache version, the OpenSSL version, SSH, you find all these other types of things, right? That's a finding. So those are the types of things you have to be aware of. Now, one of your most critical components is vulnerability research. You have to do your due diligence and vulnerability research. That's extremely important when you do this type of testing. We know we're going to have vulnerabilities in operating system devices and applications. From the external position, that attack surface, everything we discovered in our now our external testing, our scanning methodology, those types of things, is going to give us that data. So we go to our target database and we start looking at the versions of the software that we've discovered, the version of the operating system that we discovered, and now your research comes in. And then map the vulnerabilities. You can search, of course, your favorite search engine, DuckDuckGo or wherever. If you got an ASA firewall, right? As I say, and I say all the time, look for 2 to 3 vulnerability sites. National Vulnerability Database, Zero-Day Initiative, CVE details, doesn't matter. Those are some examples there. Frequent those sites, and whenever you have that data, search those sites for vulnerabilities. Of course, the exploit database from Offensive Security is a tool and a reference you can use as well to not only look for a vulnerability, but look for an exploit as well. It's good to look here on the second Wednesday of the month, after the second Tuesday of the month, Patch Tuesday, for Microsoft. Look in here and see what's available that you can potentially exploit. And here's examples for you. We love the SearchPloit tool. So we're doing SearchPloit here, and we're using SearchPloit to search for a Windows server. All this is a local repository, and in this case, your parent machine, a local repository of the exploit database. So you don't always have to go out to the exploit database. You can use the SearchPloit tool and look for different types of things. As you see here, you got Windows Server 2008. You have all these different types of things you can pick up, right? This is information you can find out about vulnerabilities, right? Different things you can do. Then we have exploit verification. So once we find these vulnerabilities, we got to validate these vulnerabilities. To validate these vulnerabilities, how do we do that? Exploitation. This is where exploitation comes in. The only way to validate the vulnerability is to gain access. So we have to exploit the vulnerabilities of the attack surface that we've researched and discovered. So, of course, you can go in and use different tools, right? So you can exploit in the case of the WannaCry vulnerability, right? SMB vulnerability here in Windows 7 Ultimate, right? Different things, information. We have to discover that information. In this case is the -A, which is the all scan with -S uppercase V, of course, the services scan. And then over here, we got a scripting engine that gives us OS discovery. So in this case, we see we have a Windows Server 2008 R2 Enterprise. So now we can start looking at different types of things. And the rule of thumb is Windows 2003 and older. So any operating system, Windows 2.3 or older, right, 2003, you might see these in OT SCADA, ICS SCADA network. Shouldn't see them in a production network hopefully today on the IT world, but they're probably still out there. But when you see that, automatically start thinking of the Microsoft Server Service vulnerability to exploit. That is MS 08 for the year 067. When you have Windows 7 or newer, start looking for the WannaCry vulnerability. And that, of course, is MS-17 for the year 2017 010, right? So that WannaCry ransomware took advantage of that port 445 open. The MS-08067 took advantage of port 445 open. So if you're mapping your attack surface from the external testing and 445's open, then you might have that potential to exploit that vulnerability. It shouldn't be open, but if it is, that's a finding in itself. And now you might be able to validate that it's vulnerable because they haven't patched the system. So we can use, of course, Metasploit. So we pull up the Metasploit tool and we start looking for the vulnerabilities that we have. In SearchSploit, you might have to do some coding. It's in PHP. It might be in Python. It's for scripting, Perl, what it is. I'm an old programmer for many years, so I look for C code. If I find C code, that's usually what I'm going to do. If it's Python, maybe I'll experiment with it. If it's Ruby, I'm usually going to just go into Metasploit because Metasploit is written in Ruby anyway, right? So these are the types of things I can do. All right, and I look and I run the exploit, right? Here it is, MS-17010. Of course, this is the famous WannaCry exploit, and we try it. And remember, exploitation is not 100%. But if you've done your due diligence and you've identified that the attack surface when you mapped it has port 445 open, moreover, you can use the mmap script to look for the vulnerability with the Nmap scripting engine, or you can manually connect to the IPC $ to see if it comes back with that insufficient server resources. That's what identifies the actual WannaCry vulnerability exists. If we have all that already, we've done our due diligence. So by the time we get to this step, we know it's going to work. Now, one more caveat. SMB v1 has to be enabled. So if you find all this and SMB v1 is not enabled, when you send that actual connection into the inter-process communication hidden share, it's going to come back with not the insufficient server resources, and that target's not vulnerable. In most cases, it's not vulnerable because SMB v1 is disabled. Now today, in the modern day, we tell everybody to disable SMB v1. So you might find the machine is ripe for the picking, in this case Windows 7 Server 2008, but the administrator was smart enough to disable SMB v1. But that's okay, because you can say you still allowed the attack surface. You shouldn't allow the attack surface of the local area network protocol from the external testing position. That's your finding. Here's another example for you when you exploit, and of course you want to see the win. When you see the win, you win. Now in this case, in this exploits payload, is just a regular shell. So you're going to have to actually update it. Now remember, upgrade it to another shell. You have a post module that will actually take any shell and try to upgrade it to an interpreter. But also you can, with Metasploit, type in sessions, space -u, space the session number, and it attempt to upgrade the shell as well. And we'll look at different techniques of that. Remember documentation. The key to all this is your documentation, because all this stuff's cool, but the client only cares what was my attack surface, what's the vulnerabilities from that attack surface, moreover, what's my risk, right? And that's what you put into your findings and into your report. Avoid the use of insecure protocols, right? Countermeasure. We already talked about this. Principal, least services, least privileges. Don't allow anything that is not required. Updates and patches, right? Reconfigure, right? The firewalls, the IDS, all that type of stuff. That's what your findings are doing. Your findings are showing them, do they find or follow best practices? If they follow best practices, you write that down as a constructive finding and say, good, I mapped all this and you had protections in place. This was your attack surface. I found 2 ports open. It's probably the business or mission need, and this was the weaknesses of those 2 ports. This is professional testing. This brings us to the end of the module. In this module, we looked at network penetration testing. Moreover, we looked at it from an external position. And by looking at it from an external position, we know there's going to be obstacles between us and the target in most cases. Those obstacles are usually some form of a device, which could be a router, or it could be a firewall. So we talked about mapping the attack surface through the device, because we only have 3 options. 1, we can attack the device itself if we find a weakness in it. We can map the attack surface through the device and only have the attack surface of what the device allows. And 3, we can bypass the device using different techniques. And we talked about how to bypass firewalls with fragmentation scans and a lot of other types of things. These are the different things we have to be able to do, not only out in industry, but also when you're practicing in your actual CPENT practice range and when you're sitting for your CPENT exam. There are devices in place. There's filters in place. You have to map that attack surface best you can from the filter. And remember, when you map that attack surface, if you identify RDP, remote desktop protocol, you identify secure shell, what you're wanting to do is when you identify those, you're going to see if you can gain access to them by running some form of a brute force attack. And that is network penetration testing from an external position. And remember, it's one of the most important things because you're not always going to be doing internal tests. Now, ideally, you'll be doing both internal testing and external testing, but sometimes the client just have you do an external test. And remember, you have a black box, and with external testing in a black box, you have what? Little to no information. You have maybe a domain name and an IP address, probably something like that. In a white box, you're given all the information, which allows you to do a lot more different things. In a gray box, you get a blend of the information. If you have a black box, one of your biggest challenges is you're going to have to determine that device or firewall, what rules are open in it, but moreover, can you determine what version of device it is? If it's a router, is it a Cisco router? If it's a firewall, is it a checkpoint? Is it a Cisco ASA? What type of vendor on the firewall? And you might have to blend some of your other information from your open source intelligence. And the last thing we'll mention here, create that target database. Make sure when you sit and you practice on the practice range, you practice recording and documenting this information as we discussed here. Make sure you, when you sit your CPENT exam, you're ready to create target databases and analyze what the network's telling you, because that's what penetration testing is all about. Remember what we said. If you send a send packet in, you get a send ACK back, that's port open. In a send packet in, you get back a reset ACK, that means once reset, the port's closed. If you send a send in, you get nothing back, port's filtered. If you get a send and you get ICMP back, more than likely the port is actually filtered by a firewall or a router access control list. Type 3, remember, is destination unreachable. Code 9 and 10, usually IP tables. Your finding first off is they're not following best practices because they're actually replying with ICMP messages. And then the type 3, destination unreachable. Code 13, communication administratively prohibited. That's what a Cisco router responds with. And with that, we'll conclude the module here.